Hey, welcome back. We're going to do some problems in section 3.3. We'll also be working on section 3.4 today. But the first thing is to classify some functions. We want to identify them either as power functions or as polynomial functions, and we can have both and neither. So let's recall a power function. The form is a coefficient times some power of x. So this first one, x to the fifth, the coefficient is 1, that invisible 1, times x to the fifth power. So that definitely is a power function. And of the others, none of them are power. No, this one is. This one, x squared cubed, it, as presented, it doesn't have that form, but we could change it, we could modify it, and see that really there is a coefficient of 1, and using the rules of exponents, if you have x squared cubed, that's the same as x to the sixth power, so that is a power function. But the other four functions, they're not power functions. In fact, the last one looks like it could be, but that's actually exponential. So let's include those. By the way, every power function is not necessarily a polynomial, but x to the fifth and x squared cubed. Let's put those in here. Here's power, here's polynomial. And those two first functions, they have non-negative integer exponents, so they're monomials, they're terms. It's enough to have one term or even zero terms to make a polynomial, and so those are both. The third one, x minus x to the fourth, we should write that as negative x to the fourth plus 4. That's in the general order, and the coefficients are negative 1 and 1. The term x squared over x squared minus 1, let's just, I wonder if we could pause. No, we probably can't pause, but let's focus in on this. I want to erase some other things. Let's get rid of some other things so I can have space to discuss this one. Okay, erase, 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 come on, erase. And let's focus on x squared over x squared minus 1. This is not a power function and it's not a polynomial as presented. The big question is there an equivalent form that does match the definition of polynomial or power function? But the answer is no. And one thing that I can justify that with is if we consider the domain. The typical things to worry about are you dividing by 0? Are you dividing by 0? Or are you taking a square root of a negative number? And in this case, we might be dividing by 0 if x squared minus 1 is 0. Well, that's x minus 1 times x plus 1. So x is 1 is not a valid input, and x is negative 1 is not a valid input. So the domain is not all real numbers. But that's different from any polynomial. If you have any polynomial, you can input any number that you want. The domain is all real numbers. So this is not a polynomial, and it's also not a power function. For a power function, 1 is always in the domain, and usually negative 1. So x squared over x squared minus 1 is neither. And let's now look at number 10. Imagine that if we use algebra, we could multiply that out and collect like terms and put it into general form. So 2x times x plus 2, even though it's not in general form, this is in factored form, you could write it as a polynomial and you'd be set. So that is a polynomial. And then this exponential function, it looks like it might be something, but it's neither a polynomial nor a power function. So that is the first problem. And let's move on to number 2.